Hey guys, this is Mohammad P, a tutor on Chegg.com. Today I'm talking about vertical asymptotes. Okay, so vertical asymptotes are basically the vertical lines that when the x approaches to a specific value, then at that specific value the y is going either to positive infinity or to negative infinity. And it usually happens when you're dealing with the rational functions and when the denominator becomes 0. Okay, so let's look at a problem here that I have. Y equal 1 over x squared minus 1. Okay. In order to find the vertical asymptotes of the rational functions, what we are going to do, we are going to set the denominator equal to 0. So I'm setting x squared minus 1 equal to 0, and then I'm trying to solve for x. So x squared is going to be 1, and then x is either negative 1 or x equal 1. Okay. So these two results are going to be my vertical asymptotes. And what do they graphically mean? They mean that at x equal 1 and negative 1, so this is x equal negative 1, I would always withdraw the vertical asymptotes with a dash line, and x equal 1. So at these two x values, the function is either going to positive infinity or negative infinity. Let's try some values. I have actually two sides to approach here and two sides to approach here. So I'm gonna try like x going to 1 from the right side, x going 1 from the left side, x going to negative 1 from the right side, and x going to negative 1 from the left side. Okay. For this case, if I plug in a number a little bit bigger than 1, let's say 1.001. So 1.001 squared plus 1. I mean minus 1. Okay. So in this case, if I evaluate the denominator, I would get 0 positive. 0 positive, it's like it's very small number and close to 0, which is positive also. And 1 divided by very small number and positive, it's going to be positive infinity. So this means as I'm approaching to the x equal 1 from the right side, the function is approaching to positive infinity like this. Now if I plug in a number a little bit smaller than 1, let's say 1 over 0.999 squared minus 1. If I calculate this, I would get 0 negative. 0 negative means it's a number very close to 0, but negative, like a little bit less than 0. So 1 divided by a very, very small number and negative, it gives me negative infinity. So it means that the function is approaching to 1 from the left side and going down to negative infinity. So as you see, I have a vertical asymptote at x equal 1. From one side it's going to positive infinity, and from the other side it's going to negative infinity. So when we are finding the vertical asymptotes, we are going to find the x coordinates of the line, of the vertical lines, that the function either goes up or down very close to that line. So you can do the same thing for negative 1 from the right and left, and you would get some result, either positive infinity or negative infinity. But I want to actually mention something very, very important that's really hard to see. Some people, they don't really know that's the case. I want to show you for the time that you get a 0 when you set the denominator equal to 0, but that's not a vertical asymptote. Okay, so let's look at the example y equal x minus 1 over x squared minus 1. So very similar to the previous one, but I'm adding x minus 1 on the top. Let's see what's happened here. So if I factor out the denominator, I would get x minus 1 times x plus 1, obviously. So in this case, I can simplify x minus 1, and I would end up with 1 over x plus 1. So this is the thing that you need to always do. You have to simplify the fraction first before setting the denominator equal to 0. Because some factors, they cancel out if you simplify. And those factors are not going to give you the vertical asymptote anymore. For example, if I say x squared minus 1 equals 0, x squared is equal 1, and then x equal plus 1 and x equal minus 1. That's not the case, because x minus 1 cancel. And if you graph this function, you are going to see, I'm sorry, here I need to say x plus 1 is not a vertical asymptote, because here, yeah, we canceled x minus 1. So if we graph this function, we are going to see that at x equal 1, we are going to have a hole. So the function is not going to have a vertical asymptote at this point, because it's already canceled, and there is no vertical asymptote anymore. So whatever is canceled from top and bottom of the function is going to turn to a hole. So it's turning basically to a hole rather than like a vertical dash line, which is vertical asymptote. And the other one, x equal negative 1, is still going to be a vertical asymptote, because here in whatever is left, if I plug in negative 1, I would get 1 over 0. So it's either plus infinity or negative infinity, depending on the side. You can check that. Okay, so I hope that you all enjoyed, and you learned these important things that is really hidden from the eyes. And I hope that you learn more things from my future videos. I try my best to actually go over more topics. And I would say goodbye till next time. Thank you.